So one thing we can do is actually show the condensed formula or the condensed structure for a molecule. And we can actually do this from the skeletal structure or from the Lewis structure. Here we're starting with the skeletal structure, and I'm going to show you how I go from the skeletal structure to something that looks more like a Lewis structure, and then finally to the condensed formula or the condensed structure. Again, these are all different ways of showing the exact same structure of a molecule. So in our skeletal structure, what we know is that they're implied hydrogens. So the implied hydrogens are not actually drawn. What we have here is a representation of carbon atoms. So here is a carbon atom, there's the second one, third one, fourth one, fifth one, and sixth one. And so this shows the chain of carbon atoms. But remember, every time we have a carbon atom, we have 4 bonds. So if a bond isn't being formed with another carbon atom, we know that we must be forming a bond with a hydrogen atom. So I'm going to go ahead and draw in my hydrogen atoms here. So I'm going to put these here. And I'm going to go ahead and show the hydrogens on this first carbon. On the remaining ones, I'm just going to draw a line. And each of these lines represents a bond to a hydrogen. And you can see now why we want to draw a skeletal structure, because when we start adding these hydrogens in, the structure gets very complicated. And the hydrogens really don't do that much. We're much more concerned about the carbon backbone and other elements. And so it's kind of a way of simplifying things. So each of these little red lines represents a hydrogen. Notice that each carbon now shows all 4 of its bonds. So if we look at the carbon right here, what we see is it has 2 bonds to other carbons, and it has 2 bonds to hydrogen atoms. So each carbon has 4 bonds total. So now we can actually draw our condensed structure, and we're going to start by looking at the first atom right here on the far left, and we look at that and we see we have a carbon with 3 hydrogens attached, and so we're going to show that by writing it as CH3. Next, we look at the next carbon atom, which is right here. We see we have a carbon atom with 2 hydrogens attached, so we write that as CH2. Going on to our third carbon, which is also a carbon with 2 hydrogens attached, so we have CH2. Going on to carbon 4, which has 2 hydrogens attached, as does carbon 5. And then we get to the last carbon, carbon 6, which is here on the end, and what we see is we have a carbon with 3 hydrogens attached. So we're going to draw that in the condensed structure as CH3. So now this shows us the exact same information, but it's a different way of showing what the structure looks like. Now, let's look at our next example. Now what we're going to do is look at our structure. We notice that there are no hydrogens drawn in. We have implied hydrogens because every carbon must have 4 bonds. So we're first going to start by adding the hydrogens to show the total of 4 bonds on every carbon. So my first carbon atom here shows 1 bond to another carbon atom. That means it must have 3 hydrogens, those 3 implied hydrogens. When I look at the second carbon, what I see is it has 1, 2, 3 bonds already because it has a single bond and a double bond. That means it's only going to have 1 hydrogen attached to it. The same thing goes for our third carbon because it has a double bond and a single bond, so that's 3 bonds formed. So now we're going to add the fourth because of that implied hydrogen. We're not just adding these hydrogens randomly. The hydrogens are there. They're just not shown in that skeletal structure. We get to our next carbon where we see we have 2 single bonds to carbon, but we also have a bond to bromine, so that's 3 bonds to that carbon. That means there's only 1 hydrogen attached there. And then we look at our last carbon and we see that it has 1 bond to another carbon, so we must have our 3 hydrogens there. And again, each of these lines, even though I've only showed it once, each of these little red lines represents a bond to a hydrogen that's present in the molecule. Now we can take the same approach as we did on the previous example, and we're basically going to kind of read our molecule. So we start on the far left and we see we have CH3. Now, when I look at the second carbon, I notice I have CH. And I go to the third carbon, I also have CH, and I don't actually have to do anything in the condensed structure to represent that double bond, because if I were to go back and draw the structure from my condensed structure, my condensed formula, what I would see is that if I just put one hydrogen on each of these carbons, there's not going to be enough bonds, and so that lets me know there has to be a double bond in there so that each carbon again has 4 bonds. So now we're on to our fourth carbon, and it is a CH, but there is also a Br attached. And I don't need to do anything different with that. I don't need to put it in parentheses or anything, because bromine is only going to form one bond like hydrogen, so I can just simply put it in the same row with no differentiation, because carbon and bromine can only form a single bond, and we can't have, say, a carbon-bromine-carbon bond. That just doesn't happen. So now that gives us our CHBr. We go to our last carbon atom, which is here on the right, and we can put in CH3. So now we have our condensed structure. Now I mentioned that the bromine did not need parentheses around it or anything. If we had had an OH group there, for example, then we would have included parentheses to show that that group was off to the side. So had that Br been an OH, and I'm going to draw that, so if this had been an OH instead, what we would have had for the structure, or the condensed formula, would look like this. And so this is showing if we had a OH there instead of the Br. And the reason we show it this way is because oxygen could actually be in the chain of carbons. We can't have a carbon-oxygen-carbon bond. We can't do that with bromine because it only forms one bond, just like hydrogen. And so because oxygen could be in the chain, the parentheses indicate that no, this isn't part of the chain, part of that main line of carbon atoms. It's actually off to the side. Now we look at our last molecule here. Again, I'm going to go through and add my implied hydrogens in. So the first carbon has 3. When I look at this second carbon, I notice that it already has 4 bonds. It has a single bond and a triple bond, so that's a total of 4. That means there are no hydrogens attached to that carbon atom. When I go down to the third carbon, I see the same thing. That carbon atom already has 4 bonds, so we're not going to see any hydrogens there. And then I go to my last carbon and put on the 3 implied hydrogens there. So I still take the same approach. I have CH3, CC, because remember, no hydrogens attached there, CH3. So now I have my condensed structure for all 3 of these molecules. So first I want you to try this one. See if you can get the condensed structure for this molecule. So now that you've had a chance to work on this, let's go through and do it together. We're going to again go through and draw in our implied hydrogens. So we're going to make sure every carbon has 4 bonds to it. The second carbon here only has a double bond and a single bond, so that's 3. It only needs 1 hydrogen. Likewise for the third carbon. We get to the fourth carbon, it has 3 bonds, so we just need to add the 1 hydrogen. And we get to this last carbon. Go ahead and draw the hydrogens in on this one since I started drawing some of them in. When I get to this last carbon, I notice that it has a double bond, so it has 2 bonds, which means it only has 2 hydrogens attached to it. And again, these are implied hydrogens. They were already there. We just weren't showing them in the structure. So now we can go through our molecule. We can actually read off what the condensed formula will be. So we start with our first atom. We have CH3. So A is a possibility. B is not, because it doesn't start with CH3. Okay, neither does C nor D. So now we're down to A and E. When I look at the second carbon, I see it has 1 hydrogen attached. My answer choice A does have 1 hydrogen attached. E has 2 hydrogens attached, so that makes this one wrong. We're going to go ahead and check the rest of A just to make sure it's correct. So we have CH, which matches, CH, CH here, which matches, and CH2. So this is the correct condensed structure for the molecule shown.